Liquid-liquid extraction.
What is the liquid-liquid extraction?
A solvent extraction involves the separation of the constituent solutes of a liquid solution by contact with another insoluble liquid. Solutes are separated based on their different solubilities in different liquids. Separation is achieved when the substances constituting the original solution is transferred from the original solution to the other liquid solution.
Purpose of extraction to separate closed boiling point mixture that cannot withstand high temperature of distillation. Example, recovery of penicillin from fermentation broth solvent butyl acetate, recovery of acetic acid from dilute aqueous solution solvent ethyl acetate.
Liquid of extraction.
Solvent solution. Extract E. Raffinate R.
The figure of liquid of extraction.
The figure showed a feed liquid, the first liquid containing the desirable compound that is to be separated together with other compounds. Then an immiscible extraction liquid, the second liquid, is added and mixed with the feed liquid through agitation. The species redistribute themselves between the two liquid phases. Agitation of the two phases is continued until equilibrium, and then agitation is stopped and the liquids are allowed to settle until both phases are clear. The two phases can then be separated.
There are two requirements for liquid-liquid extraction to be feasible.
1. Component S to be removed from the feed must preferentially distribute in the solvent. 2. The feed and solvent phases must be substantially immiscible.
The simplest liquid-liquid extraction involves only a ternary, i.e. three-component system. The solution which is to be extracted is called the feed, and the liquid with which the feed is contacted is the solvent. The feed can be considered as comprising the solute A and the carrier liquid C. Solvent S is a pure liquid. During contact, mass transfer from the feed to the solvent S occurs, with little transfer of C to S. The solvent with the solute is then allowed to separate from the carrier liquid.
Extraction processes are well suited to the petroleum industry because of the need to separate heat-sensitive liquid feeds chemical type e.g. aliphatic, aromatic, naphthenic rather than by molecular weight or vapor pressure. Other major applications exist in the biochemical or pharmaceutical industry, where emphasis is on the separation of antibiotics and protein recovery. In organic chemical industry, they are used to recover high boiling components such as phosphoric acid, boric acid, and sodium hydroxide from aqueous solutions.
In general, extraction is preferred over distillation for the following applications. 1. Presence of azeotropes or low relative volatilities are involved and distillation cannot be used. 2. Dissolved or complexed inorganic substances in organic or aqueous solutions. 3. Removal of a component present in small concentrations, for example hormones in animal oil. 4. Recovery of a high boiling component present in small quantities in waste stream, for example acetic acid from cellulose acetate. 5. Recovery of heat-sensitive materials, where low to moderate processing temperatures are needed. 6. Solvent recovery is easy and energy savings can be realized.